Hi everyone, Professor Christina Sover from Cal State Long Beach here, and in this video we will be talking about the importance of the equal sign and inequalities and what that all means in this context of this example from section 12.1 LE3. LE stands for Learning Exercises. And they talk about this relation symbol, an upside down triangle here, and it means equal sign, less than, or greater than, depending on what you plug in. It's as if in the examples that students get a lot, like 7 plus blank equals 10. What's the blank? It's just a placeholder, okay? That's how we're using it. That upside down triangle is just a placeholder. And say which of these replacements, equal to, less than, or greater than, give true sentences. They give you the first example. So x is related to x is true if the equal sign is substituted. That is, x is equal to x, but it's not true to say that x is less than x. And it's also not true to say that x is greater than x. This might not be that clear, and that's totally fine. Um, so I might plug in a number. Let's say that x is equal to 7. Well, like they have typed here for x equals to x, 7 is in fact the same as 7. But 7 is not less than 7, nor is 7 greater than 7. These last two relations here are not correct. So the only way you can plug in is if x is equal to x, if 7 is equal to 7. Matter of fact, let's go ahead and look at the other examples and see what we need to know. We've already said that x is equal to 7. We have a y come up. Let's have y equal to, I don't know, we can have it be equal to -2 and z equal to, I don't know, 12. Why not? You know what, let's make it 13 so there's not two twos going around. For this specific example, we'll go through it to see how it makes sense, and then we'll go through it in the generic. So we have, just with our example here, where 7 is x, -2 is y, and 13 is z, we have 7 and -2. Well, 7 is not equal to -2. We can't put that in there. 7 is not less than -2. Can't put that in there. So we would say 7 is greater than -2. Well, if 7 is greater than -2, well, that means -2 is less than 7. That's how they want you to go through this. However, our x and y are just arbitrary values. They're not actually equal to numbers here. So let's think about it abstractly. Looking at it now, if x is equal to y, that's only true if y is equal to x. That's kind of it for that one. If we said that x is less than y is true, only if y is greater than x. This wouldn't have worked in the case with our um, exact example of x equaling 7, y equaling -2, and let's see why that would work. If we kept x equaling to 7 and y equaling to -2, well, 7 is not less than -2. That doesn't work out. That's why we couldn't keep those standard numbers that we had over here on the side. And lastly here, Let's pretend that x is greater than y. Well, this is true if y is less than x. The intention of this process here is to note how you can read mathematics left and right to left. Um, because this statement here, this math sentence here, x is greater than y, means the same as y is less than x. So that's another cool thing about the language of mathematics. You can write it however you want, um, and it can mean the same thing in different ways. Uh, and you would just pronounce that sentence differently. Where in the first case here, we pronounce it as x is greater than y. Let me write that down. In fact, we pronounce this as x is greater than y. It has the same meaning as the statement down here, y is less than x. But you could also pronounce that second sentence as x is greater than y. Crazy stuff, I know. Let's try B. If x is related to y and y is related to x, then what can we say about x and y? So to start off, if x is equal to y and y is equal to z, well, then we want to say, is it true that x is equal to z? Well, from the first statement here, y is equal to x is equal to y, that's the same thing as we can plug in anywhere that we see a y and make it be an x. I see a y right here, so then I get x is equal to z. And yeah, totally true. That's exactly what we wanted. All they're saying is that you can plug in for the different values. In this case, the values are arbitrary letters x, y, and z. The next one, if x is smaller or less than y, and y, or sorry, and y is smaller or less than z, then is it true that x is smaller than z? I'm going to look at a number line here to prove this one. All right, let's say that this is where y is. X less than y means that x has to live on the left side of y. Now, y is less than z. That means y lives on the left side of z. So we have to put z somewhere on the right of y. Looking at this, since we know that x is less than y and y is less than z, in fact, x is less than z. And you might have seen in a textbook before, x is less than y is less than z. That's what they're saying here in this picture. So it still worked in this example as well. Lastly, if x is greater than y and y is greater than z, then is x greater than z? Well, let's use a number line again. This is a whole different number line. So what happened before is not the case anymore. I know that x is greater than y. So let's just put y, I don't know, right here. X is greater than or bigger than y means it's going to be on the right over here. And y is bigger than z, so z should be on the left-hand side of y. Well, by looking at this, we can see that z is to the left way farther plus x, and so x is in fact bigger than z. Now, This is just important to note how to read these values and how to um, gain more confidence and understanding of mathematics as a language. Um, if there's any questions, please don't be afraid to ask. I am always available as soon as I possibly can. Thank you so much for watching. Talk to you soon. See you in class.